Hello and welcome to our presentation on adapting OERs with interactive elements. My name is Veronique from Lierde.
Hello there, my name is Yasser Lamghari and I've been working on this project with Professor Lierde. And yes, I am an undergraduate student at Akhawayn University.
AUI, the university where we are, is a small liberal arts college in Morocco. We follow the North American system of higher education. The project we're working on is funded by seed money by the university. So what's the goal of this project? Well, we wanted to help our students to get to where we want them to be in our classes. Where they normally are is at the conception of calculus that is very formulaic. They think that calculus is all about memorizing formulas, plugging in numbers into formulas, and they're not necessarily ready to start engaging with the material. So there's a big gap between where the students are and what their expectations are of what we want them to do and what we actually want them to do. And what we would like to see is that the students ask critical questions, that they try to understand the concepts, that they reason with the concepts. So in class, we use daily life tools, as you can see here on the poster, to help explain the concepts. Multivariable calculus is something very visual. It's something that you can see in space, you can imagine things, and we want students to see a problem and visualize it in front of them rather than starting to compute and write formulas on paper. So another thing I do in my class is a lot of small group discussions or group work where I really want students to interact with each other and think through problems. Now, another thing I've used apart from daily life objects are visuals. When we look at textbooks, your typical calculus textbook has pictures, but it doesn't have a lot of interactivity. It's still a book on paper. Even if it's an e-book, it still behaves like a paper book. So the question was, can we make those books more interactive? And we tried to work on that by including GeoGebra visuals and self-checks. And Yasser has been working a lot on the GeoGebra visuals, so he's going to talk a little bit about those.
Well, yes, that is true. When we are students, mostly we think that when it comes to calculus, it's mostly formulas. Unfortunately, sometimes this is the case, and it may be frustrating. However, there is always a nice way in order to, let's say, visualize problems and try to understand what they are telling us. So my goal here was to, let's say, provide students with beautiful, nice GeoGebra visuals that will help them understand what is going on there, especially for some problems, some theorems. For instance, here we can see Fubini theorem. Moreover, we also have, that one ability that lets students play with the visuals, meaning they can drag points, they can use sliders, and that actually builds the intuition behind the mathematical object. And that is our purpose here, to get students to visualize and also to understand the concepts. Well, as you can see here, this is one of our latest visuals that we've been working on, and it concerns the last chapter in vector calculus. Surprisingly, most students find this chapter as challenging and abstract. Well, the reason why is because it is their first encounter with some new mathematical tools. We can here talk about divergence and curl. Well, the students here can actually interact with the visual. For instance, they can input any type of function and boom, it changes the other tab. So it's quite connected. They can also play with these sliders, increase the density, decrease the density, and also the scale. The divergence is visualized by the point L, and the curl is visualized by the point A. But then, some curious students may ask, how does it work? Well, the answer is those frustrating mathematical formulas. The point that I'm trying to make here is that the visuals are actually complementary. It is not their first encounter with these, mathematical formulas. While they are reading theorems, they will be exposed to these visuals in order to simplify and have or create a meaning for all the formulas that they see.
So when the students are working through the textbook and doing examples, They can use those visuals to improve and extend their understanding of the concepts, to start thinking in space. And then they can actually check if they understood the concepts, because we also include a couple of self-checks in the textbook. At the bottom middle, you see, for example, a drag and drop problem where the student has to match a parameterization to the matching picture of the curve in space. And they can try the activity and then they can see if they got it right. So that's a self-check, and we have several of those. Now, all the tools we use to make this are free. We're using an OER, an Open Educational Resource from OpenStax, the multivariable book from OpenStax, hosted on the LibreText platform. The LibreText platform allows you to adapt a textbook, to adopt it first, to use parts of an existing book, to modify them. And that's exactly what we're doing here. So we're just embedding those visuals and self-checks in an existing OER. And the visuals are being made in GeoGebra. The visual that you just saw with Yasser is made in GeoGebra. And we also use CalcPlot 3D, which is a tool that's specifically designed for visuals in multivariable calculus and differential equations. And then the self-tests are made in H5P. And LibreText also has a component called LibreStudio where you can also make your own H5P tests. For those of you who find this sounding very complicated, the fact that these tools are free also means that you can find plenty of free tutorials on the internet, like on YouTube, to help you get started. That's actually how I got started with them, by using all those free tutorials that are out there. Now, why are we doing this again? Remember that gap that we wanted to bridge between where the students are and what their expectations are versus where we want them to be or what we would like to see them do in the classroom. So by making the book more interactive, we're emphasizing that idea of conceptual understanding. We're also providing them with more opportunities to work on that conceptual understanding outside the classroom, because generally they use the textbook when they're on their own studying. And the self-checks give them immediate feedback, and that also leads or has the potential to lead to improved student engagement. As you're working through this project, we also learned a couple of things. So if you have an idea of getting started with this, and you may not be in mathematics, but I think this is something that can be applied in other fields as well, not just in the STEM fields, but I can imagine in other fields as well. Here's some things that we learned along the way that we want to share with you. And the first thing is to start small. So you may just start with a couple of visuals or with one chapter and work with that as a kind of pilot to see how it goes, what do you need, how is it being received by the students. The second thing is no need to reinvent the wheel. So there's a lot of material already available, a lot of these open sources that are ready for you to use. So use whatever is available and then customize it to your own benefit. And that's another big advantage of working with OERs is, first of all, it's free to the students, but you can also customize it and make it into something that works for you and your students. And then the final advice I would share is enlist the help of students, because students can give you ideas of things that for which you could make a visual, or that would be more clear if you had something to illustrate it with. That's the first thing. So you get ideas from them. Secondly, like I have Yasser working with me, students are a lot more tech savvy than we are as instructors. In general, they are. So they can also help with working out some of the technicalities there. And the third thing is your students in your class can give you feedback on the materials that you have, and then that allows you to improve those materials. Do you have anything to add to that, Yasser?
Well, yes, I do. As a student, I firmly believe that we are the source of the problems that any textbook should actually tackle. And in fact, as we said, this highlights the importance of the feedback of students. And I will just recall that in the end, the purpose of all of this is to actually improve our learning and to help us visualize concepts. That's it.
Thank you for watching. Bye-bye.